All right, lesson 3-2, solving systems of inequalities by graphing. So by the time we're done with this lesson, we should be able to solve a system of inequalities by graphing, write a system of inequalities, and find the vertices of a region formed by a system of inequalities. So to start with, a system of inequalities is it's similar to a system of equations, but with our inequality symbols. And then the solution is going to be the set of all ordered pairs satisfying all of the inequalities. Okay? So to solve, our first step is just going to be to graph each equation. So each inequality. And then find the overlapping shading. Okay, so again, we're just graphing, finding where all the shading overlaps. Now for these, when we're graphing, since it's not as important to find the intersections, it's okay just to do those graphs freehand. Or if you have graph paper, then I would just use your graph paper. So it looks like our first equation in problem 1 is a linear equation. So we are going to go up 4, put our first point. So 1, 2, 3, 4. Our slope is -2, so down 2, right 1. We're going to have a solid line because there's a bar underneath. And since it is less than, we would shade below. So I'm just going to put a couple little dashes below the line to remind myself of that. And then now we're going to graph our next one. Okay. So since we have just an x and no y, this tells us that every single x value has to be -3. So I'm going to go to -3 on my x-axis, put a point, and it's going to be a vertical line. And it's going to be a dashed line because there's not a bar underneath. And then greater than is going to be to the right. So I'm just going to put a couple little dashes to remind myself of that. Now, also when we're graphing this one, because it is a dashed line, you can also do an open circle here because technically this point is not part of our solution set. But for me and my class, this is really just to get us to graph, so I care more that you know that this is a dashed line. And then now we're going to shade where it would overlap. So I need to be below the blue line and to the right of the green line. So that's going to be in between the two lines. So that would be our final answer for that. So just to kind of reiterate what our solution set is, it means that I can pick any point in this shaded area, and if I plug it into these equations, both inequalities will be true. So let's just say that I pick the point, so if I pick this point, that is at 1, 0. So this is just kind of a way for you to check to see if you graphed it or shaded it correctly. So again, this is my x, this is my y. So I'm going to substitute 1 into the x and 0 into the y and see if we have a true statement. So 0 less than or equal to -2 times 1 plus 4. So when I simplify, we would have 0. And then -2 times 1 is -2, plus 4 is +2. So 0 is less than 2. So this is a true statement. And then it also has to satisfy this one. So there's not a y to substitute into, so we only care about the x. So I'm going to put 1 into the x. So this is for our second equation. So we would have 1 greater than -3. So again, this is a true statement. So both of my inequalities are satisfied. So I know that I shaded in the right spot. Again, just as a kind of a way to show you, let's say we picked this point up here. So 1, 2, 3, 4, 5, 6. So that would be the point 0, 6. So again, x, y. So if I substitute 0, 6 into this first equation, again, I'm going to replace the y with 6, and then 0 goes into the x spot. So we would have 6 less than or equal to negative 2 times 0 plus 4. So here this would say 6 is less than 4. Well, that's a false statement. And that should happen because this isn't part of our shaded area. Okay. So again, our solution set has to be where our shaded part is. Otherwise, either one or both of these, if we pick this point, will be false. Okay. Now, again, this is just a way for you to check to see if you shaded in the right spot. You do not have to do this every single time. All right, so if we go to the next one, kind of same idea. We're just going to graph the top equation. So this is a linear equation. So even though it's not there, we assume that our y-intercept is 0. So we're starting at 0, 0. We have a slope of 1, so up 1, right 1. We're going to connect them in a solid line because of the bar underneath, and then it's greater than, so that means that we're shading above our line. So we want the bigger y values. So again, I'm just going to put some shading there to remind myself of that. All right, next one we have absolute value symbols. So that is a V shape. So for this one, we want to start with a vertex. So my vertex is the opposite of the inside, so negative 5 and then negative 2. And we're going to choose negative 4 and negative 6. So if I substitute in negative 4 plus 5 is 1. Absolute value of 1 is 1. 1 minus 2 is negative 1. And we're going to get the same for the other one. So again, we're going to go left 4, and then down 1, left 5, down 2, left 6, down 1. And solid line, connecting it into that V shape. And then we want to shade below. So that's going to be on the outside of our V shape. So our overlap is going to be everything in between that V shape and our linear. And then down here, we're going to have to go kind of everything out in this region. So again, the red part, this is all the solutions that would satisfy both of those inequalities. So again, that means that it's going to make both of the inequalities true statements when we pick those points. All right, one more for practice. So it looks like we have two linear lines. So I'm going to go up to 5. 1, 2, 3, 4, 5. I have a slope of 1, so I would go up 1 over 1, but I ran out of graphs, so I'm going to do it backwards. So down 1, left 1. This is going to be a solid line, and we need to shade above, so that's on this side of it. Okay, next one, we are starting down at 4. So 1, 2, 3, 4, and then up 1 over 1. Again, this is going to be a dotted line. And less than, so here. All right, so when I look at this, so I'm going to make my shading a little bit bigger. So it's everything below the green line and everything above the blue line. So if I'm looking at that, that means that I don't have any overlap shading. So sometimes this does happen. So if we don't have any overlap, that means that we have a no solution for the answer. So there are no points that we can find that will make both of those inequalities true. So this is kind of a special case that happens.